All right, this is summarizing lessons 17 and 18. We were continuing to look at line of best fit and then causation versus correlation. So at least for this first part of line of best fit, we wanted to kind of go through and show how you can use the Desmos graphing calculator to show the line of best fit. So in terms of just some things to know, this little button next to most of our data, if you circle or click on anything with those colored lines or the circles, they will show or not show the data on our actual spreadsheet or graphing calculator. To then actually show the line of best fit, once you have a table of data, we're going to click this little button to the left of our table. So right now it's currently under the 5. It is that line with the 4 dots around it. Once we click that, it'll show this linear regression. That is just another term for our line of best fit in terms of our kind of straight line as we are looking. Then underneath that linear regression, you can also see that it gives us the equation. It also gives us the R value. So looking at that correlation side, so that we could then make some of these predictions and kind of analyze what is going on. If you have multiple data sets, you can kind of click them on as well by using those circles to open or close that data. This may help us compare. One of the things about our line of best fit, we can look at this slope. This current situation is looking at the number of breeding pairs of the chinstrap penguins. If I were to look at the equation, y equals negative 25.451444x plus 2,239.59373. These numbers tell me something. So this means that on average with our group, it looks like they are losing about 25 penguins per year. So as the year increases, how much is it going down by? And then that 2,239 roughly is approximately how many penguins they started when they counted with. This is just kind of taking our general average side of things. So once again, line of best fits are great models to help us make predictions, but not everything is quite set where it is. Things can change. This data could change as time goes on. Maybe this slope ends up being a little less as time goes on. The other thing we were looking at is things can be correlated, but they do not necessarily mean that they are the cause of each other. So in this example here, there is a correlation between the number of TVs owned and the life expectancy. This just means that there was some sort of a relationship between them, but it does not necessarily mean that if you own a TV, that your life expectancy gets longer. There are a lot more factors that go into play. So all in all, when looking at different headlines and stories, try to read in terms of what is actually being said, not necessarily what they might be trying to lead you towards. In terms of correlation versus causation, some things we can use to kind of help us out. Correlation is going to tell us the relationship between the two. So that is looking at those idea of the strong versus weak relationship and then the negative or positive direction. Causation, on the other hand, is saying that because one thing happens, it is going to affect another, or because this happens, this will change, or this will happen. So, like, if this happens, then this happens. So these are truly saying that this affects another one. If I drink a glass of water, then I will grow 2 feet. I don't know. Something like that is a causation kind of statement. So sometimes using this mindset will help us figure out